Welcome to this Robot Studio tutorial about the OPC UA Client Smart Component. This tutorial will show you how to connect the Robot Studio simulation to a PLC simulation environment with an OPC UA server. In this tutorial, the PLC is simulated in B&R Automation Studio. The communication between Robot Studio and Automation Studio is handled by the OPC UA Client Smart Component that is included in the Robot Studio installation. To add an OPC UA Client Smart Component, go to the Station Logic Design view and select OPC UA Client from the PLC context menu. Enter the same port number in the server address field as in the OPC UA server configuration in Automation Studio. Connect the OPC UA Client Smart Component to the OPC UA server using the Connect menu item. Select to trust the server certificate in the window that appears the first time you connect to an OPC UA server. There are two types of signals that can be synchronized with a PLC simulation: Smart Component signals and Robot Controller signals. Smart Component signals handles the connection between the PLC and the sensor and actuator smart components in the Robot Studio simulation. In this station, we have a box that is moved on a conveyor and three line sensors that detect the position of the box. The movement of the box on the conveyor is implemented using a linear mover smart component. The linear mover has a property speed and a signal execute that we want to control from the PLC program. To control the conveyor from the PLC, we have added two variables in Automation Studio: conveyor speed and activate conveyor. Later in this tutorial, we will connect these to the linear mover smart component. The line sensors in the station are implemented using three line sensor smart components. Each line sensor has a sensor out digital output signal that increases when the box passes the sensor. To send the sensor signals to the PLC, three variables have been added: Sensor 1, Sensor 2 and Sensor 3. The conveyor and sensor variables are configured to be exposed as OPC UA nodes in Automation Studio's OPC UA server. Now, let's create signals on the OPC UA Client Smart Component that will be synchronized with the variables in Automation Studio. First, open the configuration window by selecting Configure from the context menu. Use the OPC UA node browser to find the nodes corresponding to the conveyor and sensor variables. Select the sensor nodes and drag them to the input signal list. This will create three input signals on the OPC UA Client Smart Component. The signals will get the same name as the OPC UA nodes by default, but the name can be edited if desired. Drag the conveyor nodes to the output signal list. Click OK, and the new signals now appear on the OPC UA Client Smart Component. The signals can now be connected to other smart components such as the linear mover, and the line sensors. The second type of signals are Robot Controller signals. Robot Controller signals are not synchronized one by one, but instead the entire input or output data area of a Robot Controller I/O device is synchronized to a byte array variable in the PLC. The byte array variable should have the same size as the input or output data area of the I/O device. In Automation Studio, the variable robot input will contain the input to the PLC from the robot controller and will later in this tutorial be mapped to the output of the I/O device dev1. The variable robot output is used for output from the PLC to the robot and will be mapped to the input of the I/O device dev1. The robot input and robot output variables are exposed as OPC UA nodes, just like the sensor and conveyor variables. Open the configuration window again to map the input and output of the I/O device dev1 to the robot output and robot input variables. Find the robot input node in the OPC UA node browser and drag it to the device output list. Select dev1 from the drop-down menu. Drag robot output to the device input list and select dev1. Click OK to close the configuration window. The controller device I/O mapping is not displayed as individual signals on the OPC UA client smart component, but the input and output of dev1 is still synchronized with the robot output and robot input variables. In this station, there are 3 robot controller signals in the Profinet device dev1: job, job done, and start job. The digital output signal job done is used by the robot to signal to the PLC that it has finished performing a job ordered by the PLC. The job done signal is mapped to bit 0 in the device mapping of dev1, which corresponds to bit 0 of byte 0 in the variable robot input. In the PLC program, this bit is copied into the local variable job done. The group input signal job is used by the PLC to inform the robot which job to perform. The job signal is mapped to bits 0 to 7 in the device mapping of dev1, which corresponds to byte 0 in the variable robot output. The PLC program writes the local variable job to this byte. The digital input signal start job is used by the PLC to order the robot to start a job. The start job signal is mapped to bit 8 in the device mapping of dev1, which corresponds to bit 0 of byte 1 in the variable robot output. The PLC program sets this bit to the value of the local variable start job. When the box reaches line sensor 2 in front of the robot, the signal sensor 2 is set high. This stops the conveyor by setting activate conveyor to low, and the start job signal is sent to the robot. The robot reads the job signal and executes the ordered job. When the robot has finished executing the job, it signals this with a job done signal, which starts the conveyor again. When the box reaches line sensor 1 or line sensor 3, the sensor 1 or sensor 3 signals are set high. This inverts the conveyor speed and another robot job is selected. A rapid module in the robot controller uses the robot controller signals. The robot waits for the start job signal to be set by the PLC. Then the job signal is read to find out which job to execute. When the robot has finished executing the ordered job, it will set the job done signal. Enable monitor mode in Automation Studio and start the simulation in Robot Studio to see the interaction between the PLC and the Robot Studio simulation.